So now we're going to be talking about solving quadratic equations. And so this is hitting SLL number 2. And we're going to talk about solving quadratic equations by factoring. Also solving higher order polynomial equations by factoring. We're going to talk about simplifying roots and radicals. Solve quadratic equations using the square root property and solving quadratic equations using the quadratic formula. So let's first start talking about solving quadratic equations by factoring. And so just a reminder, a quadratic equation of the variable x is an equation in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0. And we have something called the zero product property, or sometimes it's called the zero factor property. If m times n equals 0, then m is 0 or n is equal to 0. So here's how we apply the zero product property. If I know that x minus 5 times x plus 4 is equal to 0, then I know that by my zero product property, x minus 5 equals 0, or x plus 4 equals 0. Well, to solve this first one, I would just add 5 to both sides. Solve the second one, I would subtract 4 from both sides. So that gives me two answers. Negative 4 and 5. The second one's a little bit more complicated, but it's the same thing. We got a product equals 0. I'm going to set each factor to equal to 0 and solve. Well, this one I'd have to add 2 to both sides. That gives me 3x equals 2. And then to solve it, I would need to divide both sides by 3. So that gives me x is 2/3. For the second one, I need to add 1 to both sides. And then I would need to divide both sides by 4. So my answers would be 1/4 and 2/3. Now the zero product property can only be used if you have 0 on one side and a product on the other side. So if we're asked to solve quadratic equations by factoring, we first have to write the equation in the right form. I need to have 0 on one side. And then I've got to make the other side into a product. We do that by factoring. Once we have it factored by completely, then we can apply the product property by setting each factor 0 and solve the resulting equations. So if I look at this problem here, solved by factoring, I do have 0 on one side, so that's the good news. So I'm going to be looking at this 9 here, this negative 9. Coefficient of the square term is 1, so I just have to find the factors of negative 9 that add up to 8. Since 8's positive, I want the larger factor to be positive. So I do negative 1 times 9, and I immediately hit the answer. I don't need to do negative 3 times 3. I don't need to write that down because I found the pair I want. So this is going to factor into x minus 1 times x plus 9. Now we go through and we set each factor equal to 0 and solve. Here I'm going to go add 1. So I'm going to use a semicolon instead of writing out the word or each time. I'm going to go ahead and add 1 to both sides. That gives me x equals 1. Here I'm going to subtract 9 from both sides. That's going to be x equals negative 9. So my two answers are negative 9 and 1. Let's try number 4. So I'm looking at this 20. Again, the coefficient of the square term's 1. Hey, we like that. So 1 times 20 gives me 21. 2 times 10, bingo, right there. That gives me 12. So it'd be plus 2 plus 10. Now use your zero factor property, set each one equal to 0 and solve. So on the first one, we'll need to subtract 2 from both sides. Second one, we need to subtract 10 from both sides. So that's our two answers. And I typically write these from smallest to largest. That's why I'm writing the negative 10 first. It shouldn't matter which order you put those answers in, Alex. It should take them either way. Take a look at number 5 and notice that's a difference of squares. Well, we know how to factor that now. That's going to be x plus 3 times x minus 3 equals 0. We'll set each of these equal to 0 and solve. So the first one, we subtract 3 from both sides. Second one, we need to add 3 to both sides. And those are our two answers. Now sometimes you might see them write the answer a little bit differently. When the numbers are the same but they have opposite signs, you might see it written as plus or minus 3. This means the same thing in this. It's just a more shorthand notation for writing this answer. So let's try number 6. Again, it's a different square. Square root of 25 is 5, so that's going to be a 5x. Square root of 49 is 7. So I have 5x plus 7 times 5x minus 7 equals 0. We're going to set each factor equal to 0 and solve. So this first one, we need to subtract 7 from both sides. And then we're going to divide by 5. And the second one, we need to add 7 to both sides. And then divide by 5. So that would give us our two answers. Or again, you can use that more compact notation. Now here's one that's a little bit more of a next level. We have 6x squared plus 11x equals 10. And the first thing we need to do is we have to get 0. So before you do any factoring, you got to get 0 on one side. And then you're going to subtract 10 from both sides. It gives you 6x squared plus 11x minus 10 equals 0. And here you're going to have to factor, either use the AC method or trial and error. Now, let's see how that works. They didn't write it out here, but let's just on the side, let's just make sure we know how we got from here to here. So if I'm doing the AC method, I'm going to do 6 times the negative 10. That's equal to negative 60. And I want to find factors of negative 60 that add up to 11. So negative 1 times 60, remember the larger numbers got to be positive, that's 59. Negative 2 times 30, that's 28. Negative 3 times 20, that's 17. Negative 4 times 15, bingo. That's what we want. So we would write the 6x squared minus 4x plus 15x. And then we would do our factor by grouping. So my first two terms would have a common factor of 2x. So that gives me 3x minus 2. My last two terms have a common factor of 5. 3x minus 2 is my leftovers, and that should be a 0 there. I don't know why I wrote 10. My bad on that. And then our two pieces have the 3x minus 2 in common. Well, 3x minus 2 times 2x plus 5 is the same thing as 2x plus 5 times 3x minus 2. So that's how they got from step 1 to step 2. And then you just go through and set each of these factors equal to 0 and solve to get your answer. So let's go and try some of these. So I'm going to do AC again. I'm going to take 12 times a negative 5, negative 60. Got to find factors of negative 60 that add up to negative 17, so I want the larger number to be negative. So 1 times a negative 60 is negative 59. 2 times a negative 30 is negative 28. 3 times a negative 20, that's a negative 17. That's what we want. So now I'm going to go ahead and rewrite this as 12x squared plus 3x minus 20x minus 5 equals 0. Let's do our factor by grouping. So looking at the first two terms, they have a 3x in common. My leftovers are 4x plus 1. My last two terms have a negative 5 in common. It's 4x plus 1. And now my two pieces have that 4x plus 1 in common, so we're going to factor that out. Now remember, we're not finished. We're trying to solve these, so make sure you then go through and set each of these factors equal to 0 and solve. So if I set the 4x plus 1 equal to 0, I would subtract 1 from both sides and then divide by 4. So one of my answers is a negative 1/4. Other one, I'm going to set 3x minus 5 equal to 0 and solve. We're going to add 5 to both sides and then divide both sides by 3. So our two answers are a negative 1/4 and 5/3.